Good afternoon, everyone. Thank you so much for being here with me. In this wonderful meeting, I'm really happy to be here, and I would like to explain to you some of the results that we are obtaining of this temperature reconstruction in one of the deepest and oldest lakes in the heart of the Maya region in Central America. And this lake is called Lake Petenitsa. It's this wonderful water body that you can see in the photo. And we will talk about the temperature changes. My name is Rodrigo Martinez, so please follow me in this presentation. In the last 20,000 years of history of the planet, we have observed an increase in the temperature above 7 Celsius degrees from what is called the last glacial maximum, followed by the gradual warming in the period called the glaciation. And from 10,000 years ago to the present, we have the stable period called the Holocene. This increase in the temperature is also together with an increase in the CO2 levels, as you can see in this record from the Antarctica, where we observe this increase in 90 ppms from the last glacial maximum to the present. If we observe the modeling data, in this case is the Shell's Trace 21K model, we will see that in the tropical area we have a cooling of approximately 2 Celsius degrees during the last glacial maximum compared with mid and high latitudes. However, if we compare it with proxy data from records like Lake Chalco or Lake Tanganyika and Clearwater Cave in the Indonesia, we will observe that the decreasing during the last glacial maximum was about 4 Celsius degrees. So this is a little bit contrasting with the modeling. And also, if we observe the continental records of temperature that are really few in the tropics, we observe differences, for example, in the deglaciation, when in the records from Central America, the neotropics, and some more or less in Africa, we observe millennial variability in the temperature compared with records, for example, in Indonesia, where we don't have this millennial variability. So to respond this gaps between the modeling, the proxy data, and also the differences between the proxy records in the tropics, we will analyze a record from this lake located in Central America. So this is Lake Petenitsa. As I told you, this lake is located in the heart of the Maya region. It's located in lowland Central America, and is one of the deepest and oldest lakes. It has a surface area of 114 square kilometers. If we compare it with an Olympic stadium, we will need 16 stadiums in order to fill the surface area of the lake. Then the modern maximum depth is 165 meters. We will need like 3 coliseums in order to have this depth. And it has a mean annual air temperature of 25.5 Celsius degrees. The lake has a stratification through the year. That means that the temperature has a reduction around 30 meters depth, and also it has a reduction in the oxygen dissolved around also 40 meters depth when we observe this anoxia on the water body. In 2006, the lake was drilled by the International Continental Drilling Program together with other institutions and obtained several records, but today we will analyze this site, the PI6. And this site is located in the northern area of the lake, as you can observe in this aerial photo. The lake is surrounded by some local communities like Las Flores City that is located here, also the Flores Insel, and also we have some Maya settlements like Nixunchik, sorry by my pronunciation, that is located here. You can observe it because the ruins are still bored. In Lake Petenitsa, we have several temperature reconstructions. However, all the methods that have been used show discrepancies between them. For example, the pollen reconstruction based on calibration curves provides an increase in the temperature from the last glacial maximum to the present of 4 Celsius degrees, compared, for example, with isotope thermometry data that, especially during the deglaciation, obtain up to 10 Celsius degrees cooling comparing with the pollen data. and the models, for example. So this brings the necessity of having new approaches with higher resolution and also in a continuous way. And that's why we are suggesting to use the glycerol-alkyl-glycerol tetraeders of GDGTs that are recently used proxy for temperature and also dissolved oxygen, because these molecules are composing the membranes of these acidobacteria living in the lake and also on the soils in the catchment. And using this proxy, we pretend to reconstruct the temperature and also some limnological variables from the lake through the last 24,000 years, so since the last glacial maximum. So this is the record that I'm going to explain to you in the following slides. We have some proxies like the humidity index, that is an indicator of precipitation, and this is based on the GGTs. We have complementary proxies like the total organic carbon versus total nitrogen, that is an indicator of organic matter source, and also total organic carbon, that is an indicator for the contribution of the organic matter. We have the dissolved oxygen that is calculated based on calibration curves and the GGTs abundances, and the mean annual air temperature that is also calculated based on some calibration curves. So let's start with the history. We have from 24,000 years approximately to 18,000 years, the last glacial maximum. So we observe moderate values of humidity index and also moderate values of TOC. So this is an indicator of moderate wet conditions and also a moderate input of organic matter. That if we observe the TOC-TN values, this is in the middle between 10 and 20 units, that is an indicator of a mixed source of organic matter. The dissolved oxygen is very variable, but in average it has a value of 4.5 milligram per liter. And if we use the oxycline, the modern oxycline, to reconstruct and to see in which how deep had to be the lake in order to have this oxygenation, we reconstruct a reduction in the water level of 40 meters. The main air temperature is around 20.5 Celsius degrees. This is up to 4 degrees lower than modern values. This is in accordance with other tropical continental records. So yeah, we will talk about that later. Then in the following period, from 19 to 10,000 years approximately, we have the deglaciation, and this deglaciation is divided in several substages. I would like to focus in the Heinrich Stadial 1 and the Jugan Trias, that are these two periods here and here. Because these periods has been really known that it were dry environments in the area, and we observe that also in this humidity index we have dry conditions. The organic content is really low because low runoff and low input of the organic matter, and the few of that exists on the sediments is mainly from aquatic sources. The oxygen dissolved is around 4, it's very variable, but around 2 and 6 milligrams per liter. And if we use the oxycline, we will reconstruct a reduction in the water level of 50 meters depth. And finally, the mean annual air temperature is approximately 15.5 Celsius degrees. This is up to 10 Celsius degrees colder than today, but is up to 7 Celsius degrees colder than the last glacial maximum. And this is unrealistic because not other records in the tropics reconstruct this decrease. And we associate this error because changes in the bacterial community. Then we have the Holocene and the Maya periods, that is the last 10,000 years, and we observe high humidity index and also high total organic content, indicating wet environments, also a high input of organic matter, and we observe a mixed source of the organic matter with an increase around 3,000 years ago. That is when the first human traces are found in the lake associated with these Maya settlements in the northern part. Then we have the oxygen dissolved that have values around 1.5 milligram per liter, that are really close to the modern ones, so that infers that the modern water levels were preserved since then. And finally, the modern annual temperature is around 25.5 Celsius degrees. That is also really close to the mean annual temperature from today. So if we compare our record with the records in the same lake for example, the pollen curve and the isotope thermometry, we observe that our curve, especially during the last glacial maximum and the Holocene, is really close to the pollen curve. And during the deglaciation, what seems to be also really similar, especially during the Heinrich stadial, as I told you, this hero associated with the bacterial community make us to think that maybe this value is not really certain. Then if we compare our record with the modeling, with the Chelsea Trace 21 model, we observe, especially during the Holocene, that where the values are really similar. The deglaciation, well, we have this error in the estimations. But something interesting is that during the last glacial maximum, our record suggests up to 2 Celsius degrees colder than the modeling. So that's also with other continental tropical records suggest that the modeling can be underestimating the values of the temperature in the tropics. Then talking about the drivers, we have this curve that is an indicator of the Atlantic meridional overturning circulation. This is an oceanic circulation providing heat to the region from Africa to the Central America. And these tendencies indicates that, for example, during the deglaciation, we have a reduction in the AMOC, and this will be affecting and reducing the temperature in the region. So with this, we fill this gap between the records in America, Africa, and Indonesia, and we observe that in this part of the world, on the tropics, the AMOC maybe is a factor producing this millennial variability, especially during the deglaciation. Finally, I would like to talk about the mean annual temperature and the association with the global CO2, because we observe that increasing the temperature in Petenitsa is also following the tendency from the CO2 values in Antarctica. So in the last 20,000 years, we have this increase of 90 ppm in the CO2, and in Petenitsa we observe a 4 Celsius degrees increase. And these changes are associated also with the increase of the water column up to 40 meters. What we observe today is that in the last 45 years, we have a similar increase in the CO2 in the atmosphere, and in the area, in a meteorological station, we observe these 2 Celsius degrees in the temperature. So maybe we can think based on the past that in the future we will have future water level increases. Well, we still don't know because we don't have meteorological records or satellite images from that period. But what we can observe in the last 5 years is that the lake is presenting every year more and more in floodings that are affecting the populations living here on the lake. So this photo is, for example, for last year in November, and this is from 30 years ago. So with that, I would like to thank you, and I'm open for the following questions. Thank you so much.